we are talking about designing respectful abstractions, and here is our agenda. Why do you need to abstract? Nobody likes to be abstracted. Why the hell is this maritime-looking guy from Germany telling me it makes sense to abstract? Second, what are the golden rules of abstracting? There are golden rules. I have made them up when I prepared this webinar, but it's the most common things that I'm always, telling people when you're building platforms. Here are a couple rules that you should probably follow. And then how do you actually design abstractions? So I will look at abstraction examples with you and design patterns. And I have a very firm idea of what I think a good abstraction is, and I have strong opinions loosely held, so you'll get my opinion. And then we are going to look at how to fine-tune those abstractions. Before we start, everything I'm saying is for the enterprise. Everything I'm saying makes sense for 50 developers onwards, 100 developers onwards. The largest, settings that I work with have in the range of 10,000 developers. If I'm saying things, always think about it from that perspective. Kaspar talks about scale. I'm interested in scale. If you're a team of 5 developers, you should use Heroku. If for some random reason you can't use Heroku, also, battle me, you can probably use Heroku, whatever. If you can't, you should use Helm charts and Terraform, and you should freestyle, and there should be chaos, and chaos should be your strategy. I think it's a way better time. So in that case, dial out, try the highcenter.ai demo. If you are in for scale, for security, for the enterprise game here, then this is something that you should look at. Don't abstract too early. That should be another rule, right? That sounds like a great additional rule, but probably not relevant enough. Again, Kaspar is about scale. Now, cool. This is some person, right? And asked ChatGPT, why should I abstract when I build an internal developer platform? And ChatGPT responded with, if you don't abstract, you don't build a platform. It's not actually true. This is actually a quote from a Gartner analyst who said that, hey, we should actually say, if you don't abstract, you don't build a platform. But there is a lot of truth to that, I think. And so that, enticing person on the right is probably a little astounded. And astounded because abstraction, the term abstraction, is something that many, many people hear and they think of nasty platforming setups of the 2010s where you wanted to have something, but then it was blocked and you couldn't actually proceed with building interesting stuff, and you had to hand in a ticket with ServiceNow, or nothing against ServiceNow, but any other of these ticketing platforms, that you hated it and you were unhappy, and then other people were abstracting stuff away, and it would take context and you didn't know what happened. You got your S3 bucket, but you don't know how it was configured. How can you do your job if you don't know how the infrastructure actually looks under the hood? How are we supposed to configure our applications? I get all of that. You're right. It's absolutely true. And this should inform our strategy, but none of those are actual reasons against abstracting. The entirety of computer science, right, as a discipline over the last decades, is a history of moving us up abstraction level by abstraction level. I mean, we are essentially at the front door of just using the English language with ChatGPT or whatever for telling our systems what to do. So abstraction is part of the game, right? There's nothing wrong with abstractions. And platforming, I put my name behind that. Platform engineering is about abstraction, period. It's a very, very important thing. Platform engineering is about commoditization, by the way, commoditization of how to build software. And if you're commoditizing, you can only do that if you move things and the consumer a level higher in the abstraction, and the consumer in our case is the developer. So yeah, platform engineering is about abstractions. Cool. So why? Now I know precisely what I still wanted to do. I forgot to build the slide, so I'm going to freestyle this. No problem. the essential bit that we have here is that you have different personas, and different personas want different things from platforms. So I actually have the slide somewhere else. Let me pull this up for you quickly. So blah blah blah. Yeah, exactly. So, and that's platforms are about commoditization of your engineering practices, but all of the different functions involved want different things from platforming. We have, the managers, they just want to go faster, a never-ending game. The finance team wants to save cloud costs. The operation teams want to drive automations. The application developers want more speed, and the architects want to drive standardization. All of this has an abstraction, or all of this is only possible. Not all of this, but a lot of this is heavily driven by, can we actually increase the level of abstraction? Why? Well, because why do the architects want to drive standardization? Or why is the actual pain point that they cannot drive standardization at the moment related to abstraction? Well, because the architects say, you should not use public S3 buckets in production. That's a problem, right? It's a problem that's impossible to solve if you don't introduce an abstraction level that says you can specify that you need an S3 bucket, but a global rule will override that this S3 bucket is not public. So architects totally need abstraction. Application developers want self-service and speed. Well, why is that not possible at the moment? Well, it's not possible at the moment because you actually sit there and say, hey, I need a new, environment, whatever. But you don't really know how to do this. Well, you could become an expert in this. You can try to hand in a ticket with security to get all of this done, but it's just really, really draining. And then so you sit there and say, hey, how do I do this? And a really easy answer is abstraction. If there's an abstract way for you to describe what you need, and then assistant gives you the defaults automatically, perfect. You solved your cognitive load problem, you solved your self-service problem, you get the speed, but you only get that with abstraction. If you're an operation team that has to go through, repetitive motions of updating version Postgres from Postgres versions from version 14 to version 15, if you don't have an abstraction and you have a one-to-one mapping relationship between workloads and the resource definition, or the sort of the running resource, then you don't get speed. You have a low level of automation. You get repetitive tickets from your developers. The solution is abstraction, because now you can say, hey, the developer says I need a Postgres. Here is the default on how to build a Postgres, but that default rule for all Postgres in an environment of staging should always have a zero drift to the actual running application. All of that is only possible if you have a high level of abstraction. Abstractions are absolutely important. Abstraction have to be everywhere. The result is CIO is happy because things move faster. The CIO only gets half of everything that we've said today because they're looking at this from another level. But that's actually one of the key problems that we're solving here for in-platform engineering. So this is the reason why you need abstraction. And this is the content of this slide, which is not really visible from this slide. Perfect. So what are the 5 golden rules of abstraction? Number 1, no abstraction at the expense of context. And I'm going to talk about all of them. Number 2, golden paths, not golden cages. Number 3, so golden paths, not golden cages means you can leave the abstraction if you don't want. Like, people vote with their feet. Number 3, abstraction is culture plus threat level. And I think you write one would write threat level with a T here. So we'll do some live debugging. Perfect. Then number 4, abstraction evolves. The abstraction tomorrow, might look different from the abstraction. Abstraction is a living thing. You should treat your platform as a product. There is no universal abstraction. That just does not exist. And number 5, don't push it, create pull. Never force an abstraction on somebody. Abstractions are actually adopted because they're better than the status quo and they change something. And if that doesn't happen, that adoption, right, then your abstraction has no it shouldn't survive. I think that's pretty vital. All right, number one, no abstraction at the expense of context. And I want to tell you a little anecdote. So when you speak with somebody who worked at Google, I've never heard them say, I really hated the engineering systems at Google. That it's just not something that happens. Like you see these inspirational LinkedIn quotes. This is my feeling after being in the real world after leaving Google 2 months ago. I miss this system. I miss this system. I miss this system. I miss Borg. I miss blah, blah, blah. Why? Well, and then actually, if you zoom in, you look at Google's system design, and our CTO has been building some of the platforms at Google, so I'm pretty familiar with that architectural design. What's so important if you look at this is that they have an incredibly high degree of abstraction. At Google, in Google, you can't say, I want my settings to look like this in production. That's just not, the scale is too large. You wouldn't even dare thinking about that. So actually, how is it possible that you have that amount of abstraction, so rigid processes, very, very clear paths and very clear guardrails, and still people get out of this tanker and say, most fantastic engineering experience that I've ever had. That's because people don't care whether you abstract them or not, as long as you do not take away context. Very, very important. At Google, they're amazing at saying, I want a thing for that context, for that situation. And then the platform will respond with, okay, here is exactly what we're going to do. We are going to give you this config. We are going to give you this resource. We're going to give you this, whatever you need. Here is exactly how we're configuring this. You can see all of the configurations. You can't touch them, unfortunately, but you can see them. Here is the internal address of the person you can reach if you want to have that changed. And that means high degree of abstraction, high degree of context. People look at this and go, well, perfect. I don't have to hand, a ticket in. I don't have to learn something, nothing. I just say what I want. Give me a thing. Here is a thing. The system responds with, plus I have all of the context and I know exactly how to change something if it's not in line with my design principles or my architectural needs. So that's rule number one. No abstraction at the expense of context. Rule number two is golden paths, not cages. And that means abstractions, wherever possible, should be the path of least resistance, if you want. Netflix calls it paved roads, a couple of funny expressions for that. But golden paths should be something that people walk on because they want to walk on this, that are so delightful that people want to stay on those paths. They should not be cages. What I mean by that is they shouldn't, unless your security posture doesn't allow otherwise, right? But if the developer doesn't find the right setting for exactly the situation they're in, they should be able to leave the golden path. They should do that themselves, be able to do that themselves. If you have a very senior kernel hacker and they love using all the intricate details of configuration options in Azure, why not just leave them as long as, again, your policies allow that? And so if you design abstractions, you have to spend a good amount of time actually designing how to leave the golden path. Significant mindshare should go into designing the door out of the path. Important rule number two. Number three, abstraction is culture plus threat level. Threat level spelled the right way, fantastic. And that means there is no universal truth on how an abstraction should look like. If you are in a highly regulated government organization or a bank or whatever, you have a culture of policy heavy culture, security aware culture. You have a lot of threat, everybody wants to attack you. And so that means it's probably okay to have a pretty rigid, pretty high degree of abstraction. If you are working in a hip startup in Mumbai, then, and security is not number one, then you probably want to have a little less abstraction, and you want to make sure that you're not over-tuning this too much. So abstraction is culture plus threat level. You really have to feel the preferences. You have to hit the preferences of the respective organizations. Number 4, abstraction evolves, just like cubism here evolved. It is a living, breathing thing. The abstraction today doesn't necessarily mean that have to be the abstraction tomorrow. People have to vote with their feet, treat your platform as a product, listen to them what they want. An interesting design principle for me is, or like a schematic way of thinking about this, is to say, if developers leave the golden path, right, they can give you hints what the next golden path might look like. If you have 6 options for a specific thing, right, but many users are opting for a 7th option, you probably want to SLA back that 7th option, make it a golden path. So abstractions evolve. You need product management, keep it as a product, listen to your users, let them vote with their feet. And then here, you should not push it, right? Many platform attempts that I'm observing fail because developers just don't adopt it. Abstraction you actually have not hit the abstraction level the right way. So I'm always saying, okay, do not push this on the user. Don't do big bangs. Start very small. Take a representative application that's as standard as possible. Structure this. Get it on an abstraction. Make sure you have a fantastic platform. Make sure this is 10 times better than everything that they're using right now. Once that is done, you can actually go ahead and they will tell their friends. They will tell the other developers. The other teams will want this. And in the most successful rollouts that I'm observing, people like this if it doesn't spread like wildfire, then you've essentially not built a good system. Okay, cool. So how do we design abstractions? And my approach of designing abstractions is to first ask myself, how do devs want to consume abstractions? Is there, do we want that through code, through portal user interfaces, through API, through CLI, through Terraform? All of this is legitimate, right? There is no universally true answer. But I'm a big believer in leaving interface choice. And I can just say, sorry, if we give users the choice what to use, and we're just zooming into one case, and I'm using this one case because I've seen it in a QBR last week. It's a financial institution out of US West, I think. Then you can see across the 16,000 something lifetime deployments this team has done in this given period of time, whatever, 98.8% of all of those platform interactions went through the code-based method. And that's not because the developers can't use a UI or can't use a CLI. That's because this is a zero friction approach to consume abstractions, which is why in most cases I'm seeing developers actually use code-based abstraction methods. And so I always tell people, probably, I do a user interface gets you into the door because the C-level loves to look at shiny dashboards, but the actual consumption happens in code. All right, a layered approach to abstractions. This is how I like to, and so I don't think you can see this, so I'm going to zoom in a little bit. And so we're going to start from here. So what is the lowest level of abstraction we are currently talking about? And would all that is already naive because it's obviously also an abstraction. But the lowest level of abstraction that we are usually confronted with in platform engineering are the configuration options of the infrastructure as code systems or on-prem systems. But even there, you have like virtualization layers. And so this might be Azure or Amazon or GCP or a combination or whatever, OpenShift. And there are like a huge amount of different options, right? Why are there a huge amount of different options? Because millions of users, whoever comes to Azure, whoever comes to Amazon, they have to make sure that they can serve them well. And so every edge case is in those configs. It doesn't mean that you need every edge case, but every edge case is in the configs. The first thing that I usually like to do is to go a little bit higher and say, okay, it's probably a truth, universally acknowledged, that if I'm zooming into any given enterprise today, and let's say they have 250 Postgres databases, I'm seeing 250 different configurations. And most of them are like tiny differences, a little bit here, a little bit there, but they're all like different, right? And then I'm always asking myself, okay, does that make sense? Like, are there really 250 materially different ways of configuring RDS? And I have the answer, and the answer is no. There are not 250 ways that make sense, right? The more surface area you have, the more cognitive load, the harder it is to maintain. So the first thing that I'm always saying is, okay, let's sit down and let's discuss what are the 80%, what is the 80% coverage? Let's configure all of the, like, we start with 3 different ways how file storage is configured for staging environments. Okay, we write recipes, resource definitions, however, you write them in whatever you want, Terraform, Crossplane, whatever. That's the first thing. We do this, and we do 3 also for every environment type. 1 for 3 for dev, 3 for staging, 3 for prod. Then we say, okay, what are the most used types of resources? We'll probably have, Postgres databases, compute. We have blob store. We have like file storage. We have DNS. We have, MongoDB. Whatever we write the types. We force rank them by usage. And then we repeat the same. We write 3 options for dev, 3 for staging, 3 for prod. And so here we get our first abstraction layer actually in our layered approach of abstractions, and that those are pre-baked configuration options of the recipes. Okay, perfect. Do we let developers consume those as they are? No. That is often the current approach, because the second you let them consume as they are, you will see drift between the actual running system and those configuration options. We have to get away from a relationship between workloads and the running resource configuration that's one-on-one, and we have to get to a many-to-one relationship. Many workloads in staging share the same definition of a database. So if you want to see this in a beautiful diagram, you have 0 commoditization. All our 7 services have completely different configurations of the same resource type. Where we want to get to are 7 services that have all the exact same configuration between the resource recipe or the definition. So we want to have 0 drift, and then we have a high degree of commoditization. So that's the first level. And now, how do we do this? We add the next level of abstraction, and that is called a workload specification. So in the end, we have the following tree. We have a workload. That workload depends on a database of type Postgres, compute, file storage, and DNS. Now, context dependent, depending on, so context being environment type, dev, staging, or production, app ID, whatever, depending on the context, this so-called workload specification, the agnostic specification of a workload, is resolved against the recipes, against the configurations that we have by type and by context. And depending on this, we are dynamically making sure we update or create the infrastructure as code layer. So that means the selection of this component layer happens automatically. The execution of this happens with every single deployment, and that procedure is called platform orchestration. So let's look at this layered level of abstractions. We have, and look at that this also introduces a certain new separation of concern. We have the workload source code up here. That's definitely in the developer domain. We have the resource dependencies and the work that is those are the workload specifications, also in the developer domain. We have the resource recipes, essentially those IAC libraries of the most common flavors by resource type, and the infrastructure, and those are cross-shared standards that are usually governed by the platform team. Now, let's say we want to take the same thing now, deploy this to Amazon for what random reason, or just to production. That means exact same specification for the developer, but now the orchestration system is actually picking different recipes to run the execution, and it's doing this with every deployment. How we describe, or how we let developers describe this, as I said, I don't care. I mean, I always leave interface choice. I usually like to use a workload specification in code. And so here we have one, open source, score, disclaimer. I worked on this as well, but we're donating this now to the CNCF. And we have here, our description, agnostic description. It's essentially exactly what you saw on the previous, slide. We say, this is my workload name. It needs a Postgres S3 and DNS. Very generic, tells us exactly what this combination needs, depending on the context, but it's not telling us what exact RDS, how this is configured. It's just giving us this abstract combination. Now then, we have the orchestration component. The orchestration takes the abstract request, goes through CI. At the end of CI, there's an orchestrator. Orchestrator is context aware, reads the deployment metadata and goes, aha, okay, that's the abstract request. Environment target is staging. Let me look at the rules provided by the platform team. The rules, if we recall, are this layer. And then it dynamically generates app and infrastructure configurations with every deployment. Every single deployment. That means by doing this, we are also updating and we are keeping the drift between the running configured infrastructure and the actual recipe to absolutely zero. And we do that through that layered approach of abstraction. And we do this in a way where it is extremely delightful to consume this for the developer. And if we run through a couple golden paths that we can construct with that, then let me give an example. I want to add an S3 bucket to an existing workload, which would today mean you take like a default thing and then you vet this and you change your application configurations and you make sure the secrets are wired the right way and all of this. And all of this is gone. You add 2 lines of code to your abstraction. I need a file storage of type S3. That operation chills, security chills, because they don't have to review this because you can see it, but you can't touch it. Essentially opaque abstractions. You never lose context and everything gets executed. Another example is I want to have a new environment. Well, if we're dynamically generating app and infrastructure configuration, it's not a problem. We just take our configuration. We indicate that this is now supposed to be a PR environment, git push, everything there. I don't have to worry about this. And then if I'm ready, it's getting tiered down. Also for operations, right? If we now want to do that upgrade between version 14 and 15, you don't need to go from workload to workload and run that thing. Right? You add that change in the recipe. The next time the respective workloads are deployed, this is running through automatically. Another example would be, okay, auditability. If we have that central orchestration system, you can run diffs and diffs. You know exactly what changed. You have a single source of truth. You don't need to go through endless, Git-based things. What went wrong in my microservice architecture? Significantly easier. Even, things like I want to replace Datadog because it's too expensive with Prometheus and dev and staging. No problem. You can enforce sidecar containers anywhere. That is now possible. Quickly talk about how are we now thinking about localizing this abstraction to the cultural context. And there are several ways. An example could be to say, hey, we want to give our developers, we want to keep them at the abstraction level, but we want to give them slightly more options. So here, for instance, before you could just say, hey, bucket should be type S3. Now you can say bucket should be type S3 where class is external, right? So you can specify more, and those things are open source. So you can essentially say, here is what we think, given our cultural context, is the appropriate level of abstraction. What is very important there is that you design these things outcome-based and not prescriptive. So you don't want to say, give me a type S3 where class is small, right? Because the reality is that you don't want to provide these misleading options to developers that you would then, from a policy layer, override in dev because you don't want to have large S3 buckets running everywhere. So those should be outcome-based, and outcome would be, I need the outcome that the S3 bucket is external and less on the more erratic prescriptive side. Now, then, what are other options to tune this? Well, how do you leave the path, right? And here, our golden rule, always make sure they can leave the path. If we recall, we now have separation of concern. We have those application source code with our workload specification. So essentially, this layer here is all in the application source code repository. This here is in platform repositories, but you can give everybody access to those platform repositories, maybe not write access, maybe only read access, but they can go ahead and they can say, hey, guys, really cute your abstraction, but I want to use Terraform and I don't want to, be bothered with these things. And if your security posture allows that, sure, no problem. Let them go off. Let them vote with their feet. Let them say, hey, your recipes are really charming, but 3 aren't enough for me. I need a 4th one. More often than not, that 4th one is not necessary, right? But sometimes there is actually a developer that is leaving the golden path. And if you see this happening over and over again, then what you've actually just observed and what materialized under your eyes is that a new golden path has been established. And that's the perfect option to say, okay, there's a fork. This is being used more and more. We're actually going to pull this into the platform. We're going to make this a 4th option on the layered abstraction level. And that is also what we mean by externalized platform as a product. It has to grow. It has to mature every single sprint. Cool. That is pretty much it from me for now. And I want to quickly make sure that my wife doesn't phone me, and then I would be happy to take questions.
Very cool. Thank you, Kaspar. Did you already check? Okay, cool.
Yeah.
So the question we have from Michael is workload specification cloud agnostic?
Yeah. Absolutely. Yeah, cloud agnostic. So the workload specification, that's the thing, right? You want on that layer, you want to have 0 cloud specific components and information. That should be something for the developer. I mean, this is, I think always a fantastic experience. If you use such a system and you can really move between the CSPs, we can share. I just did a webinar on multi-cloud platform design last week. Maybe we can share that. So yeah, the short answer is that is by design possible.
Nice. I also see a question from in the chat, but I think you already answered it with more concrete examples in the end, since this question was rather in the beginning. Do you have some more of the concrete examples? And if you want to take this one in the chat.
Yeah. So yeah, I mean, I think those examples were very concrete. But the basic truth is that this is what you make from it, right? You can have how many resource types you want. You can have whatever abstraction combination. Workload specifications like score give you a starting point of the most consumed and most used ones. I think one important thing that I think we've not really highlighted is that platform engineering is always about 80-20. That means you should not actually assume that everything you're doing is then like every single developer in your organization, every single resource, every single component will be on your platform. That is a common misconception. And I don't even think you want to aim for that. You want to, in fact, make it clear very early on in your design phases as you're pitching this also as an initiative to the managers, that you are not intending to build something to rule them all, but that you're building something that is 80-20. I don't know any platform in the world, even the ones that have been around for a long period of time, that are actually able to cover 100% of the estate. And that might be because, so I'm typically seeing, if you're building a platform in a security heavy environment, then you'll see adoption levels when you're doing it well between 80 to 90%. In organizations like that are a little less rigid historically, it is hard to impossible to go over let's say 80%, right? And you're seeing ranges from 70 to 80%, right? That's doable, but beyond that is usually difficult.
Nice. Well, you guys are typing out either the last question or next question. I would like to ask you to give Kaspar a break and submit your topic to the platform engineering webinar series. We are compiling the calendar for 2024. So if you can, if you have built your own internal developer platform and want to share your story, I don't know, waiting for you. Usually there is a call line, you know, like all I want for Christmas is a platform engineering story. But yeah, if you have any questions, let's give it another second to let you finish it. But if not, we'll say goodbye and happy holidays.
Yeah, and don't be shy. Submit your stories. Submit stories that where you failed. Those are often more important than those shiny things where everything always worked, because that does not exist. So don't be shy to show us failure as well. And if there are no further questions, I think we're all slightly exhausted from the year. It's been an uphill battle for many of us, I presume. Thank you very much for sticking around with us, for letting us be part of your learning journey, for your contributions, for your participation in the community. That is very much appreciated. Thank you, Maria, for organizing this, being on so many calls. I mean, at least only live, you've been probably in way over 60 sessions this year. I mean, tell me anybody else who's seen more content on platform engineering. I'm sure that's always what you wanted. So thank you very much for organizing everything and for sticking with us. To all of you, happy holidays.
Happy holidays. Thank you, Kaspar. And see you next year, guys. Have an amazing celebration and spend lots of time with your loved ones and eat lots of delicious food. That's all what we deserved. Cool. Thank you.